Okay, I believe you can all see that now. I'd like to echo Lisa's comments on welcoming you all to this careers event. We've said that it's aimed at parents, but obviously, hopefully there are some students watching as well. And you're welcome. We're doing on Saturday another 2 of these. There will be different speakers at every event. So if you would like to go to all of them and meet all of the speakers, that would be absolutely fantastic. The reason we've made this one more of an adults one is more to do with the questions and the kind of things that you might be asking at the end. So all the way through this evening, you are able to ask questions. What we will do is collect them all together and do them all in the Q&A at the end, but you can ask the questions then, or you can ask them as we're going through, but they will be answered at the end of the whole evening. So I'm going to start off with my presentation because I have come to the space industry quite late. So what I'm going to do is tell you a bit about my background, also tell you a bit about the space industry and where I think careers are going in the future. But before we get cracking on it, I'd just like to point out to you that at the moment, one of the other projects we're doing is being sponsored by the UK Space Agency. We are creating careers videos. In fact, we finished recording them all and they're just being edited now. And as you can see, we have some fairly expected space people on there, like aerospace engineer, public communicator, space weather expert, but we've also managed to include some things for people who perhaps aren't thinking about a career in science, but still love the idea of space. So we've got a space business manager, an education manager, an astronomer, a space lawyer, and a space artist as well. So they will be available from January onwards. If you come through to the National Space Academy website after January, you'll be able to find them there and continue, because obviously due to time we only have 3 speakers this evening, but with the 3 speakers today, 3 in the morning on Saturday, 3 in the afternoon on Saturday, and then another 8 here, you'll be all spaced out. You can also choose the ones that you'd prefer to see. So for those of you, some of you I'm sure have a career in science, some of you maybe don't, but there's something I always like to do when I start speaking to school children especially, is to say a few things that I've done in my career. And out of the following ones, only one of them isn't true. And so hopefully you'll be able to guess that. So done an experiment with beads so radioactive, I had to control it from another room, taken part in an armed police chase, been asked to hold a skunk, shaken hands with somebody who's been on the moon, broken the law with immunity from prosecution, done experiments at an Antarctic base, made contact with a Russian ex-general in a hotel lobby, had lunch with Brian Cox and given Jim Al-Khalili a lift in my car, spent a weekend dressed as a suicide bomber, complete with real Semtex, given a BBC radio interview about an RHS flower show without knowing anything whatsoever about gardening, watched the commissioner of the random police fire a real gun multiple times at a virtual pot plant, and designed a girl guiding badge that was completed by 25,000 people in 2.5 years. So as I say, only one of those is something that I've not done in my science career so far. Some of them will hopefully be answered in the next few minutes. But I'm also a storyteller, and a lot of good stories start out with failure. And originally I wanted to go to medical school. So I spent a year at medical school. I had an ambition to burst through a set of double doors in a hospital wearing a white coat and not be asked to leave. And that was achieved in Wandsbek General Hospital in the March of 1997. Unfortunately, by that time, I discovered that I never wanted to be a doctor again. So I switched to a course called Physics with Medical Applications and did my first piece of research, which was anisotropy and brachytherapy, which was inserting highly radioactive beads into cancerous tissue. From university, instead of becoming a medical physicist, I actually became a forensic physicist. And so a forensic physicist is somebody who does research into various physics principles that can then be used to work on solving crimes, fighting crimes, and various things like that. So you're probably guessing that kind of things we do there might lend themselves to some of the things I've been talking about having done in my career. So there's various places at this facility. They invented automatic number plate recognition. They do all of the equipment for airport security, police weapons systems, fingerprints, tracking devices, bugging devices, you name it, it's pretty much all there. And so that was quite a good fun place to be. So my initial job was in the Less Lethal Weapons program, where we looked at all kinds of weird and wonderful things like net entanglement systems and ray guns and stuff that you squirt at people to make them all sticky. And of course, those things were utterly ridiculous, and we absolutely were not going to use them. We also had a look at handheld water cannon systems, and this is actually a really ridiculous system. And one of my most embarrassing photographs, because the Metro newspaper got hold of it and ran it with a story about all these crazy systems that the police were considering looking at. And so if you Googled boffin, laughing stock, that kind of thing, then you would see that picture of me on Google for quite a long time. But then I did get into more serious things. I spent 4 years assessing tasers, whether they work, whether they're going to kill anybody, whether they are effective, and so on. So I did a lot of that. And then I moved into counter-drugs and counter-terrorism, where we were looking for drugs in the fast parcel environment, in the kind of post environment. And we were doing that with low-angle X-ray scatter. So basically, if you fire X-rays into a crystal, they will come out at an angle which will then be unique to the kind of crystal that it's going through. That's the what the system looked like. And we got to the point where in about 1 second we could tell what things were mixed with and in what proportion. So that was the first 7 years of the career. I include this one because mixing the drugs was something I had to do, and I include this picture because that's incredibly rare. That's a physicist in a white coat. We generally don't wear them. And then I went off to work for the Institute of Physics, and I worked with universities across the region. I worked with industry on outreach and public engagement. By the time I finished, so I spent about 14 years at the Institute of Physics, and I figured out by the end of it, I'd spoken to about 65,000 people over that time about physics. We organised science festivals. I've met various interesting people, including Brian Cox, Johnny Ball. That's probably one that I wouldn't include in the ones for the children. The guy on the right there is Martin Rees, who was Lord Rees, the Astronomer Royal. That was the first selfie I ever took, and the first one he'd ever appeared in. And the reason he's looking kind of sideways at me like that is because I'd screwed it up about 3 times, and that was the 4th one. Dame Jocelyn Bell Burnell is an incredible woman. She discovered pulsars. And although she didn't win the Nobel Prize for it, other people did, she's been very gracious about it, and says that it means that people give her another prize every couple of years. And the most recent one, I think she won several £million, and she's given the whole lot over to a scholarship fund for widening participation, getting girls and ethnic minorities in to do physics at Oxford and Cambridge. And that is Charlie Duke. He did not want to shake my hand, but I forced him to anyway because he's been on the moon. He was one of the 12 astronauts who went on the moon. I got to lobby MPs, which is entertaining or not, as you might imagine. Handling weird animals. Whenever at a science festival, people just shoved animals into my hands. Appeared on radio shows, including on Radio Gloucestershire, talking about an RHS flower show. I also write, so I've written articles on physics, but I also write novels as well. So that's kind of a potted history up to my current job, and now it's all going to be space and science from this point onwards. So I now work for the National Space Academy. That is our logo in the cupola of the International Space Station. And we're based at the National Space Centre. So for those of you who've not been, it's in Leicester. Top left-hand corner, you can see the building and the very iconic tower that sticks up there. That has those 2 rockets that are in the middle there in it. And then on the bottom right, you can see a Soyuz capsule, which is the most complete Soyuz spaceship on Earth outside of the former Soviet Union. And so we welcome many visitors to the centre. We get about 80,000 school children visiting a year. We get about 300,000 people in total in a year coming to it. And we also have the National Space Academy, which is something that you're listening to right now. So the National Space Academy focuses on secondary school pupils and also teaches CPD. We go into schools, and since we opened more than 10 years ago, we've actually delivered masterclasses to over 60,000 pupils across the country. We try to do this as cheaply as possible, or if we can get people to sponsor it for free. And we also do careers events, both in person and online careers events. So you're attending one of those online ones now. So let's have a think about the future of science, the future of physics, the future of space in terms of jobs. And one of the weirdest things about working in the tech industry and the space industry and so on is that many of the jobs that the young people today are going to do not exist yet. So how on earth are we supposed to prepare children for careers that don't exist? How are we supposed to advise them on what they want to do? And it's all about, for me, it is about finding something they love and getting them to do that, to do it well, and inspiring them to do it. And obviously, as a scientist, I would love them all to do science because, as you've heard in my own career, you swing backwards and forwards between different jobs. You do one thing, then you do another. And by doing certainly at least one science at A level, or possibly more of them, then you're opening many doors in terms of careers. So what jobs didn't exist just 10 years ago? So driverless car engineer, social media influencer, blockchain analyst, podcast producer, telemedicine physician, cloud architect, Uber driver, drone operator, chief listening officer, bud tender, big scientist, contact tracer, esports game coaches, online dating profile writers, apparently that's a job, TikTok marketer. So these jobs, some of them you may not have heard of, like bud tender. A bud tender is somebody who advises you on how to consume your legal cannabis in certain countries. But most of those, hopefully, you will have heard of, and all bar two of them were able to come into existence because of advances in technology and advances in science. So where do we look for the future? Well, let's think about some things that we found in the past and nobody knew what they were going to be able to see. Nobody knew what they were going to be able to use them for. So an electron, there used to be a toast in, I think, the Royal Society or somewhere like that, where they said, to the electron may we never be useful for anything. And now we run our entire world on electrons. The X-ray was found completely by accident. Nobody was looking for it, and it's incredible what we can do with it now. The man who invented the laser first invented a maser. So laser stands for light amplification with stimulated emission of radiation. But they did it initially with microwaves. And somebody asked him, could you do it with a laser? And he said, yes, but why would you want to? And now all of our global communications, including you watching this, are based on lasers. And then one of the most esoteric things, the Schrodinger's cat and quantum science, what possible use could there be? Well, tunneling electron microscopes already exist, and the whole world is running headlong towards quantum computing. So what's the mystery at the moment? What's going on at the moment? Well, there's a new dark matter map. These are all from the last year or so. There's a dark matter map. We don't know what dark matter is. We don't know what dark energy is. CERN experiment hits a new force of nature. So various places, experiments around the world are finding little wobbles and things that show that the standard model of existence don't really make any sense. And then up in space, of course, enigmatic fast radio bursts. We don't know what they are really. We think that one may have been something to do with a magnetized dead star, but it's still very much something out there that we don't know. And certainly in the time that I speak to school pupils, there seems to be a certain idea that everything is known now, and all you have to do is Google it. So if we can convince our young people there is a lot of stuff we don't know yet, and you can be paid very well and have an entire career looking for it, then we're doing well. So I went to Physics World, the magazine, to say they did a prediction of what's going to happen over the decade ahead. So Li-Fi is going to be a thing. You've heard of Wi-Fi. Well, you can put infrared emitters in the ceiling, and these can actually go far faster than any Wi-Fi at the moment. Quantum computing, as I've already spoken about, is both scary and important and good. I don't know if anyone's heard of the quantum apocalypse, but if you had a quantum computer and programmed it correctly, you could break any kind of encryption that currently exists in the world. And so the UK government is already funding some heavy research towards quantum computing to say that so that we can be ahead on it. Artificial intelligence and machine learning, this is very much something that we're already doing. It's already heading towards us. And I was looking this morning at artificial intelligence that can actually draw pictures for you. So you tell it what you want drawn and it will draw that picture for you. Medical imaging, within the next 10 years, we are probably going to be looking at devices that can show what's happening in the body in real time in 3 dimensions. The James Webb Space Telescope is now up there and functioning and sending back absolutely magnificent stuff. So if you were to draw a little 1 millimeter square on your thumb and hold it out like this, the little patch of sky that's covered by that thumb, with the Hubble Space Telescope, when that looked at that patch of sky, it saw 5,000 galaxies, each with 100 million or so stars. Now, James Webb is looking at the same kind of patches of sky and is seeing far more. So there may be a heck of a lot more in the universe than we think about. And then we've got gravitons and looking at those. So there are experiments already. LIGO experiment, we expected to hopefully see gravity waves within the first few years of operation, and we got it within the first few months. And so these things are happening far more than we thought. And then, of course, there's the Artemis program. Human beings are heading back to the moon, and probably the year after next, there will be astronauts on the moon. And this is a staging post, and a lot of people really do believe that human missions to Mars, maybe not landing immediately, but human missions to Mars will be occurring by the end of this decade. So what's happening in the UK? Well, you're going to be hearing about opening of UK spaceports this evening with one of our other speakers. The Rosalind Franklin rover may or may not still do something. It was supposed to be going up with the Russians, so we've had to have another look at that. There's a lot of talk with European Space Agency about space-based solar power at the moment. They could put, they're talking about entire solar arrays that could are the equivalent of a full-blown power station on the Earth, but putting it in space and sending the energy back via microwaves. The Skylon space plane, and specifically its Sabre engines. So this is a hypersonic aircraft that would be able to go to Australia in just a few hours. The expansion of CubeSat missions. If you've not heard of CubeSats, these are small cubes about this big, and you can actually put satellite experiments in them, and then you launch a whole bunch of them on a rocket at the same time. They will stay in orbit for just a few days, but you'll be able to do experiments in them while they're up there. Looking at new alternative ways to deliver SatNav, and the OneWeb satellite company. So that is about internet connection. And just this morning, it was announced that several locations in the UK are now that are incredibly remote are going to be connected to Elon Musk's version of this to give them web access for the first time. The next UK astronauts, so European Space Agency last week announced new astronauts, including a British woman this time, and also the first disabled person in the European Space Agency astronaut program. And the giant green and blue elephant in the room, what on earth am I talking about? Well, of course, the Earth, because my boss at the Space Academy talks about the 3 things that we do in space. One of them is looking out there. So it's the astronomy I was talking about. It was looking at the dark matter. It's looking at the James Webb Telescope and looking at stars and so on. The second thing is going out there. So that's robotic exploration. It's the Artemis program with astronauts going back to the moon. It's going to Mars and so on. But the biggest and possibly, I think, most important thing is looking back at the Earth. And why is that so important? So obviously there are now thousands of satellites in the in orbit around the Earth. That's a picture of one at the National Space Centre. So that's the flight spare of a Meteosat. So if the actual satellite had blown up on the rocket, this one would have replaced it and gone up in space. But as the first one was successful, it wasn't needed. So it now hangs in one of our galleries. So looking at the weather and the climate is obviously an incredibly important thing. And this is why I think it is. The Earth is in a bit of trouble. It's like a patient in intensive care. And if you think about a patient in intensive care, they are linked up to lots of machines that are monitoring blood pressure, they're monitoring blood flow, they're looking at breathing, they're looking at your oxygen content and so on. And what we have is a planet where we need to make changes and we need to look at what's happening. And that is what satellites do. In real time, they can check what's happening, what changes will do to it and so on. So here's an example of NO2. This is a really quite toxic pollutant, and you can see the clusters of it around industrial areas. So you can see it in kind of the northeast United States, in Britain and Northern Europe, and a huge amount out there in China as well. But I'm going to look at this one specifically. So this is over New York. And you see in March 2015, 2016, you can see a huge cloud of this stuff, down a bit in 2017. And you probably figured out where I'm going with this, and hopefully you saw it in the news at the time as well. It's because lockdown happened and the whole lot disappeared. So it shows, I mean, this is not a good thing. We don't want lockdowns, we don't want COVID or anything like that. However, it shows that we really can affect change. If we do things, satellites can show us that we are achieving things. This is another piece of information we get from satellites. So NDVI, V stands for vegetative or vegetable. I can't remember which one it is. Anyway, so what you see here on this one and the one after, you can see the amount of foliage on the trees and the amount of green cover in the fields in the UK between June and October. So all of this, you can see long-term trends, you can check year after year what kind of effect climate change is having on greenery and so on, but you can go right down to farming levels, and farmers are actually able to use satellite technology now to monitor their crops without even going out there. And you could then use agricultural robots and artificial intelligence and put it in with that, and we could actually be farming without a huge amount of people involved. Climate change, the cost of living. So all through the summer, we could see where fires were going to break out before they broke out. So it was actually, we saw the predictions, and then we could look at the satellite images of where those fires actually were. And this is an interesting one as well. So people can live on heat. You may have heard of heat islands. So if you live in a kind of like a place with a lot of built-up area and no green spaces and so on, you can you live in a hotter area, and we can actually map that onto maps of the UK, and we can see the areas of social deprivation, and then you can actually link social deprivation with heat islands and see how climate change affects different rich people and poor people and so on. So we are hopefully dealing with it. Nuclear power is coming back, solar power, wind power, and so on. Are we really getting anywhere? Yes, we are. The amount of CO2 this country produces in power production is going down and down, and we are getting to points where we don't use fossil fuels at all on some days. One big experiment that's going on, what do these countries here have in common? Well, it is the International Thermonuclear Experimental Reactor. So this is harnessing the power that drives the sun. This is fusion technology, and they are building it in the south of France, because where would anyone love to go and work? Yes, the south of France. But in the UK, at the Jet Laboratory, we actually proved that this could work, and the image you can see on the right is actually several seconds of fusion energy happening. And the reason we had to stop there is that the magnets were not powerful enough in this country to keep going, and they would overheat. So the cold magnets in the south of France will keep this going, and this is going to work, and it's going to happen in the next few years. And of course, talking of things going round very quickly, the world's most famous synchrotron is still throwing up all kinds of information that relates, and I know this is a space thing, but it all relates together. It's the experiments being done in here are, this is the Large Hadron Collider, by the way. These experiments are just linked to all kinds of space physics. You can see it's an enormous thing. But these are international collaborations, and one of the great secrets of a career in science and technology is that you get to travel around the world at other people's expense, either collaborating in these big things or going to conferences and stuff like that. And of course, one of the biggest international collaborations in recent years is the International Space Station, an absolutely magnificent piece of work with these 5 countries involved in it, and it's been up there, well, 4 countries and the European Space Agency, which is a whole bunch of other countries. And this is the kind of thing that gives me hope for the future, because this is the only international thing really left that Russia is still involved in. And you can argue either way whether they should still be there or not. And given the whole thing that's going on with Russia, I hope it will come to an end one day, and then we're going to have to move forward as a world. And I'm going to illustrate this with just a couple of slides left now. And this was tweeted from space. They called it the ISS's saddest photo, and it was during a battle between Israel and the Palestinian area of the Gaza Strip. And they could actually see missiles going backwards and forwards between the two countries. And some Middle East history, a lot of these countries do not like each other. Turkey and Cyprus do not get on. Egypt, Jordan, and Lebanon have all fought Israel. Israel has an ongoing situation with the Palestinians. Iran thinks that Israel shouldn't exist. Pakistan equally thinks so. And why am I going on about this? It's because of something called Sesame, synchrotron light for experimental science and applications in the Middle East. And these are the countries that run that system together. And you can see that Iran and Israel and Palestine and Pakistan and Turkey and Cyprus, they're all around the same table. They're all in the same place doing physics together, doing science together. And these are the countries that actually support it as well. You've got the People's Republic of China and the UK and the United States, and a lot of people who are not usually around the same table, all working together on science. So I think that the children, the students who are coming out in the next few years are entering a world of uncertainty, but they are entering a world that can be fixed, and they are going to be the ones who are going to have to fix it. And I think space, particularly science collaboration, and everyone around the world needs to get together to work on this. And I recognise that not every student, not every child wants to be a scientist. However, if we can convince everyone, if we can convince you that science is a good thing and we should be doing it and that the problems can be fixed, then we can also have the lawyers, the space lawyers helping us out. We can have the accountants, we can have the ministers, the civil servants, the government ministers and everyone else all on the same page. So I think the careers future in space and in science is bright. I thoroughly hope you will all recommend your children to look into it. And I think they can fix the world for us. Thank you.